Before we start solving rational inequalities, let's have a review first of writing interval notations and set notations. Because when you solve rational inequalities, the solutions that you will solve or you will find are written in set notations and interval notations. So remember, in interval notations, the smallest term from the interval is written first, while the largest term is written second after a comma. And then we use parentheses to signify that the endpoint or the number included in your interval is exclusive from your solution. So, ibig sabihin, it is not part of the solution. Then, we use brackets to indicate that the endpoint or the number is included in our solution. Some examples of interval notations and the set notations is here. So let's say the set notation includes x greater than a. So this means that you have x values higher than a. So if we write that in our interval notations, we'll have parentheses a, comma, to positive infinity, parentheses. So as you can see, we used parentheses before a because in our set notation here, the inequality used is greater than a, meaning a is not included, just the numbers that are greater than a. And then the same thing for the second one here. Since we used less than, x is less than a is still not included. That's why we made use of the parentheses. And then here on the set notation, x is greater than or equal to a, you will notice that we already made use of brackets because we have greater than or equal to. It means that a is already included in the set of solutions. And when you have two numbers, when your solution are in between two numbers, we make use of this kind of set notation. A is less than x and x is less than b. So we have here parentheses between a and b because a and b are both not included in your solutions. But if you see an equal sign, greater than or equal sign, less than or equal sign, it means that your solutions are included. That's why in the interval notation, we'll make use of brackets. So now let's try solving rational inequalities. And these are the steps when you solve for rational inequalities. First, make sure to write the inequality in a form such that on the right side of your inequality, you only have 0. Next, determine the critical values of your rational inequality and then you can test them. The number 3, we'll use the critical values to separate the number line and form intervals. And then for the fourth step, we'll check each interval if they are included in our solution. And then lastly, we'll express our answer or the solution of your rational inequality in interval notation form or in set notation form. So let's say you're given x plus 2 over x minus 3 is less than or equal to 0. So you will see here that step 1 is already done because on the right side of your inequality, we already have 0. And then on step number 2, we solved for the critical values of the numerator and then the denominator and tested them if they are included in the solutions of our rational inequality. And then for the third step, we had our number line and then separated them using using the critical values to form intervals. And then for the fourth step, we'll check if each interval is included in the solution. And once you have done all that, we can now write the solutions using the set notation or interval notation. So let's try solving this one. 2x plus 10 over x plus 3 is greater than or equal to 1. So you will see here that on the right side of our equation, we have 1. It is not 0. So that means for our first step, we have to write it in a form wherein on the right side is only 0. So that means we have to transpose 1 on the left side. Therefore, our inequality will be 2x plus 10 over x plus 3 minus 1 is greater than or equal to 0. And then after transposition, we have to simplify our rational inequality on the left side. So we have to perform the operation 2x plus 10 over x plus 3 minus 1. And since this is subtraction, we have to find the LCD. And our LCD here is x over 3. So we'll have x over 3 minus x plus 3 as our denominator. To find the numerator, just divide and multiply. So x plus 3, our LCD divided by the original denominator, x plus 3, 1, times 2x plus 10, you'll still have 2x plus 10. Then LCD divided by the denominator of 1, which is 1, is still x plus 3. Times the numerator 1, this is x plus 3, is greater than or equal to 0. So since we already have our LCD, we have the same denominator, we can just combine the numerator. So we'll have 2x plus 10 over 2x plus 10 minus x plus 3 all over x plus 3 is greater than 0. And to combine your numerator, since it's subtraction, we'll have to make use of keep change. We have to keep the minuend, 2x plus 10, and then change the signs of the subtrahend. So we'll have negative x and negative 3 all over x plus 3 is greater than or equal to 0. Summarizing them, you'll have 2x minus x, that is x, and 10 plus negative 3 is positive 7 all over x plus 3 is greater than or equal to 0. And from here, we'll be able to find our critical values, which is the next step. To find the critical values, we can just factor the numerator and denominator, then equate them to 0. So for our numerator, x plus 7, this is already non-factorable, so we'll just equate it to 0. And then we'll solve for the value of x, and our x here is solved by transposing 7 on the other side, and we'll have x equal to negative 7. So this is our first critical value. And we'll test if it belongs to our solutions. So to test, we'll just insert or substitute negative 7 to our original rational inequality. So from 2x plus 10 over x plus 3 is greater than or equal to 1, we'll have 2 times negative 7 plus 10 over negative 7 plus 3 is greater than or equal to 1. Simplifying, we'll have negative 14 plus 10 over negative 4 is greater than or equal to 1. And this will give us negative 4 over negative 4 is greater than or equal to 1, which is 1 greater than or equal to 1, and which is a correct inequality. So that means negative 7 is included in our solutions. Next, we'll do the same thing for the denominator. We have x plus 3 equal to 0. So our critical value here is negative 3. And then we'll check this again. So from the original inequality, just substitute negative 3 and you'll be given 2 times negative 3 plus 10 over negative 3 plus 3 greater than or equal to 0. And this will be 6, negative 6 plus 10 divided by 0 is greater than or equal to 0. And since we already have our denominator equal to 0, that means this is undefined. So if your answer is undefined, then that means negative 3 is not part of the solution. So after testing your critical values, we can proceed with step number 3, which is drawing a number line. So from step number 2, we have the critical values x equal to negative 7, which is included in the solution, and x equal to negative 3, which is not included in the solution. So drawing our number line, so let's say negative 7 is somewhere here and negative 3 is somewhere here. Since negative 7 is included, we'll make use of a closed circle, while on negative 3, which is not included, we'll use of an open circle. And as you will notice, our number line is divided into 3 intervals. The first one is the numbers on the left of negative 7. So that's our first interval. X less than negative 7. So we'll test this interval by using any numbers included in the interval and inserting it to a rational inequality. So let's say we want to make use of x equal to negative 8. So we'll have 2 times negative 8 plus 10 over negative 8 plus 3 is greater than or equal to 1. So this will give us negative 16 plus 10 over negative 5. It's greater than or equal to 1. And negative 16 plus 10 is negative 6 over negative 5. It's greater than or equal to 1. And this will give us positive 6 over 5, greater than or equal to 1. For you to identify easier if the fraction is greater than or less than the value on the right side of your inequality, you may also write the fraction in decimal form. So 6 over 5 in decimal form is 1.20. So 1.20 is greater than or equal to 1. And this inequality is true. Therefore, this interval is included in our solutions. Next interval is the numbers between 7 and 3. So that is -7 is less than x, but x is less than -3. So we can choose x is equal to -4. Do the same thing, just substitute. So that's 2 times -4 plus 10 over -4 plus 3 is greater than or equal to 1. 2 times -4 is -8 plus 10 over -1. Greater than or equal to 1. And this will give us positive 2 over -1 is greater than or equal to 1. And -2 is not greater than or equal to 1. So this is not part of the solution. And for the third interval, we have the numbers after 3. So that is x greater than -3. So we can use, let's say, we want to use 0 because 0 is greater than -3. So 2 times 0 plus 10 over 0 plus 3 is greater than or equal to 1. So this is 0 plus 10 over 3 is greater than or equal to 1. So we'll get 10 over 3 is greater than or equal to 1, which is 3.33 in decimals. So this is greater than or equal to 1. And since this inequality is true, that means this interval is included in the set of solutions for 2x plus 10 over x plus 3 is greater than 1. So to summarize, the left side is included in our solutions. The second interval is not included. And the third interval is included in our solutions. So for step number 5, we can write the set notation and the interval notation by referring to the number line. So that means we have the numbers from -infinity until 7, which is included. And since you have 2 or more intervals, we'll use union to indicate that there is another interval included in the set of solutions. And that is from -3, which is not included, until positive infinity. So this is how we write the interval notation. And then for the set notation, we can just write x is less than -7 and x is greater than -3. For another example, let's have 3x minus 15 all over x is less than or equal to 5 minus x. So we'll just be following the same steps. The first one is to write this inequality in a form such that on the right side you only have 0. So that means we'll write this as 3x minus 15 all over x minus 5 minus x is less than or equal to 0. Then we'll perform the operation on the left side to simplify it. And since this is subtraction again, we have to find the LCD. And our LCD is x. So we'll have x minus and then x. X divided by x is 1 times 3x minus 15 is 3x minus 15. And then here we have x divided by the denominator, which is 1, that is x, times 5 minus x, we have x times 5 minus x is less than or equal to 0. Then this will be 3x minus 15 over x minus x times 5 is 5x, and x minus x is negative x squared all over x is less than or equal to 0. So simplifying, we'll have 3x minus 15 minus 5x minus x squared all over x is less than or equal to 0. And then we'll use KCC since it's subtraction. So 3x minus 15 minus 5x plus x squared all over x is less than or equal to 0. So from here, we can summarize this, or we can simplify this to x squared minus 2x minus 15 all over x is less than or equal to 0. So if you have changed your rational inequality in the form wherein on the right side you have 0 only, we can now find the critical values and solve for them or test them. So our critical values from the numerator, we have x squared minus 2x minus 15 equate it to 0. And x squared minus 2x minus 15 can be factored to x minus 5 times x plus 3 is equal to 0 using the sum and product pattern. So that means from the numerator, you'll get two critical values. So that's x minus 5 equal to 0. And transposing, this is x equal to positive 5. This is our first critical value. Then we'll test it using the original rational inequality. So that is 3 times 5 minus 15 divided by 5 is less than or equal to 5 minus 5. So this is 15 minus 15 over 5 is less than or equal to 5 minus 5 is 0. And 15 minus 15 is 0 divided by 5 is less than or equal to 0. And you'll get 0 is less than or equal to 0. And here we have a correct inequality. So that means 5 is included in our set of solutions. Another critical value is from the second factor, which is x plus 3. So we'll use that again. X plus 3 is equal to 0. And we'll get here x is equal to negative 3, which is our second critical value. And testing it again, we'll substitute that to the original inequality. And we'll have 3 times negative 3 minus 15 all over negative 3 is less than or equal to 5 minus negative 3. So this is negative 9 minus 15 over negative 3 is less than or equal to 5 minus negative 3 is positive 8. So negative 9 minus 15 is negative 24. Divided by negative 3 less than or equal to 8, that is positive 8 is less than or equal to 8. And again, this is a correct inequality, so this is included in our solution. And then for the denominator, we have x. So we'll just have x is equal to 0 as the third critical value. And we will test that also. So 3 times 0 minus 15 over 0 is less than or equal to 5 minus 0. 3 times 0 is 0 minus 15 divided by 0 is less than or equal to 5. So you will notice that on the left side of our equation, we have 0 in the denominator. So it will be undefined. So since this is undefined, we cannot compare it to positive 5. So that means 0 is not a solution. So if you have your critical values and have tested them, we can now proceed with drawing the number line. So from step number 2, we have the critical values. X is equal to 5, x is equal to negative 3, and x is equal to 0. So 5 is included, 3 is included as well, while 0 is not included. So on step number 3, if we draw the number line, so let's say negative 3 is somewhere here, and then 0 is here, while 5 is somewhere here. So negative 3 is included, 0 is not included, so open circle, and 5 closed circle. So you can see that here we have 1, 2, 3, 4 intervals. So that means we have to test all those intervals. The first interval are the numbers less than negative 3. So that is x is less than negative 3. So we can use the number negative 4. So just substitute it to our original rational inequality. We'll have 3 times negative 4 minus 15 all over negative 4 is less than or equal to 5 minus negative 4. Simplifying, 3 times negative 4 is negative 12 minus 15 over negative 4, less than or equal to 9. And this will give us negative 12 minus 15 divided by negative 4, that is positive 27 over 4, is less than or equal to 9. And 27 divided by 4 is 6.75. So 6.75 is less than or equal to 9, which is true. So the first interval is included in our solution. For the second interval, the numbers between 3 and 0. So negative 3 is less than x, but x is less than 0. So let's try using x is equal to negative 1. So that's 3 times negative 1 minus 15 over negative 1 is less than or equal to 5 minus negative 1. Simplifying, 3 times negative 1 is negative 3 minus 15 all over negative 1 is less than or equal to 5 minus negative 1 is 6. Negative 3 minus 15 is negative 18. Negative 18 divided by negative 1 is positive 18. Positive 18 is less than or equal to 6 is not true. So this is not part of our solution. For the third interval, we have numbers that are in between 0 and 5. So 0 is less than x and x is less than 5. So let's try using x is equal to 1. Substituting, you'll have 3 times 1 minus 15 all over 1 is less than or equal to 5 minus 1. Simplifying, 3 times 1 is 3 minus 15, that is negative 12 over 1 is less than or equal to 4. And negative 12 divided by 1 is negative 12, less than or equal to 4, which is a true inequality. So that means this interval is included in our solutions. And then for the last interval, we have the numbers on the right of 5. So that is x is greater than 5. So let's just use 6. Substituting again, that is 3 times 6 minus 15 divided by 6 is less than or equal to 5 minus 6. 3 times 6 is 18 minus 15 over 6 is less than or equal to negative 1. 18 minus 15 is 3 over 6 is less than or equal to negative 1. 3 over 6 is 1 half or 0.5, less than or equal to negative 1, less than or equal to negative 1. And this is not true. So it's not included in the set of our solutions. So since we have tested all the intervals, we can proceed with step number 5, which is writing the set notation and the interval notation. So for the interval notation, you will see that the numbers on the left side of negative 3 is included. So that means we'll start with negative infinity. So negative infinity until negative 3. And negative 3 is included. union, we'll use union because we have another interval, which is from 0 up to 5. So 0 is not included. That's why we'll use parenthesis 0 until 5, which is included. So we'll use bracket. And then for the set notation, we have set of numbers x such that x is an element of real numbers and x is the first interval, which is less than, but negative 3 is included, so we'll use the less than or equal to symbol, negative 3. Or we'll have or because we have another interval, that is, I'll just write here below, 0 is less than x and x is less than or equal to positive 5. We have less than or equal to positive 5 because 5 is included. And then we'll close the set using braces. For the third example, let's have 1 over x minus 1 is less than 2 over x plus 2. So the first step is to rewrite our equation, our inequality, since on the right side it's still not yet 0. So by transposition, you'll get 1 over x minus 1 minus 2 over x plus 2 is less than 0. Performing the operations on the left side, subtraction, so we have to find the LCD first because we have different denominators. And since both the denominators are non-factorable, the LCD will just be the product of the factors. So that means we have x minus 1 and x plus 2 as the LCD. For the first rational expression, divide and multiply. LCD divided by original denominator. So we'll eliminate x minus 1. You'll be left with 1 times x plus 2. Then the same thing for the second one. This is LCD divided by original denominator. Cancel x plus 2. So we'll have 2 times x minus 1 is less than 0. Simplifying, this is x plus 2 over x minus 1 times x plus 2 minus 2 times x minus 1 is 2x minus 2 all over x minus 1 times x plus 2 is less than 0. Combine the numerator, that is x plus 2 minus 2x minus 2 all over the LCD, x minus 1 times x plus 2 is less than 0. Then use the keep change since this is subtraction. So we'll have x plus 2 minus 2x plus 2 all over x minus 1 times x plus 2 less than 0. Combining like terms, we'll get x plus negative 2x, that is x. And 2 plus 2 is positive 4. All over x minus 1 times x plus 2 less than 0. And from here, we can proceed with step number 2, which is finding the critical values and testing them. So from the numerator, we have x plus 4. which is non-factorable. So we will be equating that to 0. And our first critical value is -4. Testing that by substituting -4 to the original rational inequality, that's 1 over -4 minus 1 is less than 2. 2 over -4 plus 2. And this will give us 1 over -5 is less than 2 over -2. So we can rewrite this into decimals to identify easier which is higher or lower. 1 divided by -5 is -0.20. And less than 2, 2 divided by -2 is -1. So this is not true because -0.20 is not less than -1. For the denominator, we can get here two critical values because we have two factors. So let's start with x minus 1 equal to 0. Critical value is x equal to +1. So testing it, we'll get 1 over 1 minus 1 is less than 2 over 1 plus 2. We'll have here 1 over 0 is less than 2 over 3. And 1 over 0 is undefined. So we cannot compare them. Therefore, this is not included in the set of solutions. And then for the third critical value, we have x plus 2 is equal to 0. So this is x equal to -2. So testing that, we'll have 1 over -2 minus 1 is less than 2 over -2 plus 2. So 1 over -3 is less than 2 over -2 plus 2 is 0. And again, this is undefined because we have 0 in our denominator. Therefore, we cannot compare them. That's why this is also not part of our solutions. From step number 2, we have the critical values -4, +1, and -2, which are all not part of the solution. But in step number 3, we can still use them to find the intervals in our number line. So let's see, this is the number line. -4 is somewhere here. And let's say -2 is here. +1 is here. We will mark all of them with an open circle because they are all not part of the solution. And for step number 4, we'll test the intervals. The first interval is are the numbers on the left of -4. So that is x is less than -4. Let's use -5. So test it by substituting -5 to the rational inequality. So we'll have 1 over -5 minus 1 is less than 2 over -5 plus 2. So this is 1 over -6 is greater than, is less than 2 over negative 3. 1 over 6 in decimal form is negative 0.17. Well, 2/3, 2 over negative 3 is negative 0.66. So this is not true. So that means the first interval is not part of the solution. For the second one, we have numbers between negative 4 and negative 2. So negative 4 is less than x and x is less than negative 2. So let's try x equal to negative 3. So that's 1 over negative 3 minus 1 less than 2 over negative 3 plus 2. This is 1 over negative 4 less than 2 over negative 1. 1 over negative 4 is negative 0.25 less than negative 2, which is also not true. So this is not part of the solution as well. For the third one, we have between negative 2 and 1. So negative 2 is less than x and x is less than 1. So let's try using 0. We have 1 over, that is 0 minus 1 less than 2 over 0 plus 2. So this is 1 over negative 1 less than 2 over 2, which is negative 1 less than 1, which is true. So this is part of our solution. And then for the last interval, the numbers on the right of 1, that is x is greater than 1. Let's try using 2. So we have 1 over 2 minus 1 is less than 2 over 2 plus 2. This will be 1 over 1 less than 2 over 4, which is 1 less than 1/2, or 1 is less than 0.50. And 1 less than 0.50 is not true. So this is not part of the solution as well. So therefore, in step number 5, the final answer, we have in interval notation, negative 2 not included until 1, which is also not included. Since we only have one interval, we'll not use union anymore. And then for the set notation, we have set of numbers x such that x is an element of real number and negative 2 is less than x and x is less than 1. So that's our final answer.